So I've been doing a lot of work with seventh graders this week and doing multiplying and dividing and adding, subtracting with integers. And I kind of started thinking about this way of using what I know about parts and wholes and this bar graph model, double bar graph model, excuse me, bar model, to figure out how to add and subtract integers. And let's see if it makes sense. So the idea goes, if I have two rectangles on, pretty much superimposed on top of each other, these two parts add up to this part up here. They have the same value. So if I take this part and this part add up together, it's going to be the same as this one. So just thinking here, if I had a part, this part A and B, according to my model, they're the same size, they're the same length as C. So I can add them up and figure out what C is. And if I know what C is and A is, and I know what this part is, I can figure out this other part. Like I can do subtraction, I can do C minus A to get that one, or if I know what B is, I can use that to find A. So let's use some practical numbers. So for example, here's a double bar model and I have a 5 and an 8, and I know that if I add them together, 5 and 8, I'm going to get 13. So I can just add them together to figure out the missing number, and of course my missing number has to be 13 because that's the only thing 5 and 8 can add up to. Or if I know what my total is, 19, I know this part is 7. So if this part up to here is 7, what part does this have to be to give me 19? Well, so I have some kids who go, Miss, why don't you just take away the 7 and you get 12? And I even have some kids who just decide 7 plus some number makes 19, 7 plus 12 makes 19. So there's a lot of great algebraic thinking that goes into this. So I can use models where I can have the total and a part and I can figure out the missing part, or I can take two parts and figure out the total here. So how does this work with 7th grade math? So I was thinking of problems like this where I can use a number line to kind of represent this, where I start off with something like, here is negative 8 3/10, and I know it is 8 3/10 away from 0. And if I'm adding 6/4, so from negative 8 3/10, if I'm adding on a number, it's not enough to get past 0 because 6 4/10 is not bigger than 8 3/10. It's not as big. So I can make another box on top of it, and I just have to figure out what this part is. And even though these numbers have decimals, it's the same theory. Here's a total. I have a part. I just need the other part. So 6.4 plus some number makes 8.3. I could just turn it into a subtraction problem. 8.3 minus 6.4 to give me some number. And I can stack it and figure it out. So let's see what that looks like in another model. I'm going to draw a quick number line. I'm going to have my 0. And I'm going to start with 5 and 93 hundredths. Negative 5 93 hundredths. And I want to say it correctly. And I know this is 5 and 93 hundredths from 0. And I want to add another negative number. So since I'm adding a negative, I'm going in this direction. I'm going further away from 0. So I'm going to put it right next to it. I'm adding another, I want to go another 2 and 48 hundredths away from 0. So I already have two parts. I just have to figure out what this part is here. And I can take these two numbers and really add them together. So let's do that. 2 and 48 hundredths and 5 and 93 hundredths. My decimals are aligned. I don't need any placeholders. I can just add it up and get 8 and 41 hundredths. So I know that this, if I add these two together, I get to 8 and 41 hundredths, and obviously it's farther from 0 to the left, so I know it's a negative. So that would be my answer. Negative 8 and 41 hundredths. I always get a little antsy to make sure my math is right. 11. This would be 10 plus 4, 14, and 8. Yep. All right, so let's look at another situation. So I'm starting here again. So I'm going to draw another number line. And I'm going to go to negative 2 and 63 hundredths. Again, my bar is how far am I from 0. And this time I'm going to add a positive. So that means I'm definitely going in this direction. And 4 and 96 hundredths is much bigger than 2 and 63 hundredths. So I know I'm definitely passing 0. So here I have a different model. I still have my 2 bars. And I know the total is 4 and 96/100ths. I have a part. I just need the other piece here. So I can just think, well, I can take this number and take away the part to figure out the other part. So 496 minus 263 is going to give me my missing piece. For those who like stacking, which I don't mind at all. So I can just see my math. I get 2 and 33/100. So that's where this number ends, at 2 and 33/100. That's what this part is right here. And being that it's to the right of 0, I know it has to be a positive 2 and 33/100. So I really like these models because they help me really see and think about things like distance from 0, which is a big part of Common Core math. How far are these numbers from 0? The other part I like about them is I can do some thinking work even with fractions. And 7th grade is notorious for mixing fractions and decimals. So let's start with 1. Here I have 3 and 4/10, and it's a positive. I'm sorry, 3 and 1/4. So here's 3 and 1/4. And this time I'm adding a negative number. So I know I'm going towards the left. And just by looking at it, if I'm moving 4 1/2, that's much bigger. It's a little bit bigger than this number here. So here's 4 1/2. And I need to know the value of this number here. Okay? So I have my total. If I take away this part, I'm going to get this part. So 4 1/2 minus 3 1/4 is going to give me that number. Of course, I want my denominators to be the same. For those of us who are having trouble with that, you can just check out some of my other videos. But for now, here I can already see that my common factor is going to be fourths. So 4 and 2/4 minus 3 and 1/4. And I personally can do this in my head, but I guess some people do like to see the stack. There's no regrouping in this problem either. So 2/4 minus 1/4 is just 1/4. 4 minus 3 is just 1. So n is equal to 1 and 1/4. But now remember, if I'm over here, if I'm going to 1 and 1/4, I'm to the left of 0, so it has to be a negative. That's the other thing I like about this method. As much as I completely get a lot of kids telling me, you know, Ms. Fuentes, I know how to do this. Why do I need to do all this stuff? But it helps me in a lot of ways. It helps me really think about, where are my numbers from 0? So I'm really thinking about that. Am I to the left or to the right? Am I positive or negative? Am I adding a positive integer? Am I adding a negative integer? Am I moving past 0? How my distance from 0? So I'm really thinking about integers in another way when I'm doing this type of model. So for the 7th graders at our school, I hope this really helps and in doing your homework tonight. If not, I will see you tomorrow. Thank you.